All right, let's get started here. We have our Moog Modular V synthesizer here, the Arturia Moog Modular V soft synth. And the real advantage of that for us here is that we connect modules together with virtual patch cords by dragging between the various inputs and outputs. And what that lets us do is really see those connections very clearly and what those modules do in terms of affecting each other and the overall sound. So what we're going to do now is get started with the very simplest possible sound, which is just a sine wave oscillator going out to the system. So I'm going to click and drag here on the sine wave output and take it over to a VCA here. And this VCA is going to be triggered by our external USB keyboard that I'm working with here. So what is happening here is we've got a sine wave coming out to the VCA. The VCA is going to be triggered by the keyboard, our external keyboard, and the external keyboard is going to be triggering an envelope which is going to be controlling the amplitude of that VCA. And so we're going to get, in fact, an envelope sound and a very simple, straightforward synthesizer kind of sound. So as I just press the keys there, we get that trigger sound. A very simple, very straightforward sound. Now, what is sample and hold? Sample and hold, in fact, doesn't per se have anything to do with sampling, digital sampling, the digital sampling that we're all familiar with. But there are some points of reference between those concepts. And essentially, when you sample something, again, in the larger world, when you sample something, you take a reading of something at a particular point in time. So that could be you're taking a sample of the population, for example, which means a smaller section of the whole set and polling them for political purposes or what have you. So a sample is really a smaller section of a larger something that you are taking at a particular point in time. In the digital world, when you talk about digital sampling, what that means is that you take an analog sound and you take a reading of its amplitude at a particular point in time and convert that into a digital number. And you do that enough times so that when you play back those digital numbers, you get an approximation of the original sound. So that in, say, when you're recording a CD, for example, you're doing that, in fact, let's say you've got a guitar plugged into your CD recorder. And what you're doing, in fact, is taking a sample at the rate of 44.1 thousand times a second, in fact. So every 44/100,000ths of a second, you are taking a reading of that sound coming in and grabbing a section of that and turning that into a digital number. And you're doing that 44,100 times per second, which is the 44.1 kilohertz sample rate that CDs work at. So that's a digital sample. In the analog world, sample and hold is somewhat similar in that we're taking a reading of an analog signal at a particular point, but we are then holding that signal until we take the next signal. So what that means essentially is that we are going to be taking a changing analog signal of some sort and putting that into our sample and hold module, which is this thing right up here, and taking a reading of the signal coming in, of that voltage that's coming in at particular points in time, and then spitting that back out again. And so what we're going to do in the next video here is show you exactly how that works.